Okay, let's get started. Thanks everybody for joining today. My name is Damian Roskill and I'm the Chief Marketing Officer here at AppNeta. I'm pleased to be joined on this webinar by my colleague Sean Armstrong, who heads up product here at AppNeta. Oh, thank you. Yeah, that's a good thing to start with, right? Let's show some pictures. Anyway, I'm pleased to be joined here on this webinar by my colleague Sean, who heads up product here at AppNeta. Here's our contact information if you want to reach out to us. Here at AppNeta, we're fairly obsessed with end user experience when it comes to business critical applications. But the question that our customers often ask us is how metrics relate to end user experience. So for today's webinar, we thought we'd talk about 5 key metrics to think about in monitoring any cloud application and why they're so important. In terms of our overall agenda, we'll get started today by talking about the new world we find ourselves in, as well as some historical context on where we're coming from. Then we'll get into discussing metrics and how they relate to end user experience, and how the cloud has left IT with some blind spots. We'll also be showing some interesting data on cloud provider performance along the way. I think you're going to be really interested to see, because it's certainly not what I expected. But before we get on to all that, let me just get through some logistics. We're going to be recording this webinar, and we'll be sending out the recording afterwards. So if you've missed any portion of it, don't worry, we'll be sending it out. If you have any questions, and we do love getting questions, please type them into the chat window, and we'll get to as many of them as we can at the end of the webinar. Just a reminder in terms of time here, we're targeting this webinar to last 30 minutes, so we're going to be moving pretty quickly. So let's take a brief walk down memory lane here. In the old world of IT, measuring performance was relatively simple because you owned all the infrastructure. And because you own the infrastructure, it was easy to get metrics from all the devices. Servers and router metrics could be easily aggregated across your organization. And the networks were all owned or leased by the company, and IT had clear visibility between, say, a remote location and or a home office and data center. In this world, metrics like jitter, packet loss, latency were all straightforward to measure. Now let's look at the new world that we find ourselves in. It's a world that's highly distributed. Your offices are distributed, your users are distributed, and the applications that they use are now distributed across data centers and multiple SaaS providers. You know, where before you owned every part of the application delivery chain, now you own very, very little. And yet IT is still responsible for the performance of these applications. And adding to that pressure is the increasing importance of application performance. It's pretty common knowledge that tolerance for slow applications is decreasing. We've all abandoned a website when it was too slow. Yet most organizations considering a move to the cloud aren't considering how that move will impact the slowness of the application or the speed of the application. Moving an application from essentially a local host to the cloud introduces network as this new dependency with variable latency. And when it comes to web-based apps, latency is a little bit like compound interest. And that's because web apps are really chatty. They often make dozens or even hundreds of requests to build or load a single web page. And each of those requests will be impacted by that network latency. And the end result is a slow page or slow loading system. Add hundreds or even thousands of users, and that small increase in latency, it suddenly began to make a huge impact on your overall productivity of your organization. And that hit in productivity can be significant. Yet, I'll be honest and say this is an area that I've seen IT really struggle to quantify to their CIO or CEO. So what I've got up here on the screen is a simple example that we created. It's just a calculator to show how 1% downtime could have a huge cost. In this simple example, even assuming a modest salary for each employee, if you've got 500 employees, a 1% downtime is going to translate into at least $250K in lost employee productivity cost. Bottom line is that the productivity loss is real and it can be quantified. Oh, and by the way, if you're interested in this calculator, we've created a little Google sheet with all of our calculations. We're going to be providing that at the end of the webinar, or rather, I think we're providing it in the email that follows on. And hopefully you can find that useful maybe as a starting point for building your own business cases. Now let's look at a real example as it relates to application performance and where you host the app. What we've got up here is a performance comparison of the same open source CRM application running across 3 different cloud environments. What we did was we started by setting up identical infrastructure on AWS, Azure, and Google, and then installed the CRM application. Next, we're then running synthetic web transactions as well as our own active path technology from 2 of our 60 global points of presence to these applications. We're running the same application automation script with the same steps from the same locations to the same application hosted in these 3 different providers. The application is the same, but the performance is very different, and thus the end user experience is also very different. In this case, the application hosted by AWS is approximately 3 times as fast as the one hosted as Azure and Google. The next question to ask is why? And so if we drill in a little bit more, what's interesting here is a clear delineation between these services in terms of network and server metrics. Azure is being impacted by poor server performance in comparison to Google and AWS. But the other really interesting thing about this data, from my point of view, is to note the variability or variance, right? So it's not consistent, it's not constant. You can be hosting applications with one of these providers, and they can suddenly become non-performant for reasons that are out of your control. And that's going to impact your end user experience. And that's why it's so important to be continuously monitoring these kind of metrics and monitoring your application from just an overall continuous point of view. So clearly, if you're interested in end user experience and deploying to the cloud, you need to be concerned with network metrics as we should with latency. But what are other metrics that matter, and why do they matter? So with that, I'm going to pass the mic to Sean to talk us through the 5 metrics you should be tracking and how they relate to end user experience.
Great. Thank you, Damien. So now we're going to dive into a number of traditional network metrics that you can use to uncover user experience issues in your organization as you transition to SaaS and cloud services. So these key performance indicators largely have not changed from when you were monitoring these applications within your own environment. What really has changed is the application delivery path. They've gone from your data centers, your network, and out over the internet and into SaaS and cloud service providers. This application delivery path is now largely outside of IT's control. The metrics that you used to be able to collect directly from your environment, your devices, are now being generated by devices owned by third parties and simply aren't available to traditional IT management systems. Additionally, some metrics that you weren't collecting or really paying that much attention to before are now very, very critical as these apps are geographically distributed from your users. So first off is latency. So this is probably the most frequently monitored metric. This is both one-way latency and round-trip time. And when you were running these applications in your own data center, you may not have been paying any attention to latency. An app run in your data center, co-located with your users, may have a response time of 1 to 2 or 3 milliseconds. That's how these applications were designed. They were designed for very, very responsive networks, and that's what you had when you control the entire environment. Now that you've moved this application to the cloud, you've introduced the internet between your users and the servers running these apps, and you'll have an RTT of 30 or 40 milliseconds. This problem is compounded by the types of applications used, web applications. A web app is not one monolithic file that's downloaded, but it's really a series of requests and responses from the client to the web server. And this increase in latency, going from 3 or 4 milliseconds to 30 to 40 milliseconds, is going to be felt on each one of these requests and each object downloaded. And when this is a business critical application that your employees are using all day, it can have a major effect on their productivity. This isn't a e-commerce website where they're just going to shop somewhere else. If this is in Salesforce.com or some app you're running in AWS, your employees have no choice but to deal with this slowdown in the app's performance. And this metric of latency, as evidenced by the cloud provider example we just reviewed, is critical. You need to make sure you choose the right provider with the right hosting locations to ensure the best performance for your users and the success of your application. Once you identify that latency is the problem, you need to figure out where this latency is occurring. Is it in your network, on your Wi-Fi, for example? Is it in your WAN connection? Is it over the open internet? Or is it even in the service provider environment? There are a few basic troubleshooting steps you can take, like measuring if it's the user or the host. Well, are other apps on this network experiencing problems? Are other users of that app experiencing problems? If it's just select users, it's probably a user-specific issue. If other apps being consumed from the same location are not having a problem, it's probably not a common resource like your WAN connection or your ISP. It's probably something specific to that application. If it's location-centric, let's check other locations within your environment. Are they having the same issues with the same applications? These are all designed to really triangulate and identify where is this issue occurring so that you can really cut the problem in half at each step of the way to get to the root cause and resolve this as quickly as possible. Beyond these basic steps, you need more advanced tools. Simple methods like traceroute aren't going to solve this problem simply because how the internet is architected. A traceroute will give you a rough idea of the path taken from the user to the application server, but the internet is asymmetric. It's going to take the most efficient route from source to destination, as well as from destination back to source. And there's no guarantee that route will be the same in each direction. So when you just do a trace route, you have a single point in time measurement of the route and the latency along the layer 3 hops from source to destination, but it tells you nothing about that return leg from the destination back to the source. And most web applications, you make one small request for a web page and you get back 10 to 50 times the volume and number of bytes transferred from the server back to the client. That return leg is actually the more important of the two in most scenarios. So, latency is all about perception. It's all about how users feel about this application, and it does require that you measure this in an asymmetric fashion. You try to measure both directions as they are both critical to the application's performance. How this affects end users' experience with their application, and really their overall productivity within your company. Next is packet loss. When you're hosting these applications internally, packet loss probably was not a concern. Network device vendors do a wonderful job. Packet loss simply doesn't happen on a LAN that often, and when it does happen, it's usually something very straightforward to find and resolve. On the open internet, packet loss is much bigger of a problem and much more difficult to identify what the root cause is. Within data applications, typically TCP-based applications, you're going to be using a delivery method, a protocol that has guaranteed delivery. But the problem is you need to detect when this packet loss is occurring because each packet that gets lost with the TCP application will be detected and resent. This level of retransmission adds congestion and latency to your adds congestion to the network and latency to your user's experience. This is to the point where 1% packet loss can have a material effect on a user's experience with an application, sometimes contributing up to 40% slowdown in the application's load time, even at something that seems very low, 1%. And at 2%, it will increase the overall time to load any given page upwards of 8 to 10 times if that application experienced no packet loss. This can have an extremely detrimental impact, even at these low packet loss levels, to your user's experience and whether that app is actually usable to the average person. This varies between data and voice applications. Voice over IP and video conferencing use specific encoding algorithms called codecs, and codecs are designed to handle some level of packet loss. Depending on the codec you're using, you may be able to sustain 3, 4, or 5% packet loss before the voice quality or video quality really starts to degrade. But once you get to that 5% level or anything higher than that, the video quality will degrade, and will degrade quite noticeably. The audio will start to cut out or start to sound robotic. The video will freeze and get very blocky. Things that are very, very noticeable in a video session or a voice session, where you may not initially notice them in something like email, where that email will eventually get through. That with too much packet loss, that voice call might just drop altogether. And it's very critical that you measure these independently because the type of traffic sent by a data application and a voice application are very different. A data application will use what are called full MTU packets. It's going to detect what is the largest size packet I can send over this network, and I'm going to use that largest size because that's the most efficient way for me to transfer data. On most networks, this will be a 1500 byte packet. A voice over IP call, for example, will use much smaller packets, 64 or 80 byte packets, a fraction of that full NPU size packet used by that web application. And networks treat small packets and large packets differently. So you need to be able to understand not just is packet loss occurring, but is it only affecting a specific type of packet on my network? Because which type of application will be affected is a direct result of what type of packets are being suboptimally shaped or lost altogether within your environment. Next is capacity. This is very straightforward. This is where most people typically start. If a web application is slow, let's just upgrade our bandwidth. Let's just go get some more capacity. This is a very common refrain. Salesforce is slow. I'm going to go from 50 megabits a second up to 100 megabits a second. That'll solve the problem. Well, that's really not the case. Your connection to the internet is probably not the limiting factor in how quickly this SaaS or cloud-hosted application can be used by your users. And this is a common misconception about capacity. This is not a measurement of the ingress-egress point from your network to your internet service provider. What really affects your application's performance from a capacity perspective is the highest point of congestion from where your users are to where the application is hosted. Basically, what is the bottleneck point between your users and the app? And that volume of capacity is what is going to determine how quickly your application is going to run and how good of a user experience your employees are getting. This is very critical when you're looking at transitioning to cloud services. If you're going to something like AWS, you can specify exactly how much memory you have, exactly the CPU available to your virtual machines, exactly how much storage you're going to use. One thing that's rather opaque is the network speed that's actually available to the VMs you just moved up into the cloud. If you were to just look at that virtual machine, you may see a 1 gigabit virtual network interface defined for that VM, and wonderful. You think you have 1 gigabit per second, but if you read the fine print and you actually look, the most common image size sold by AWS, an M3 medium, actually has a guaranteed performance level of under 80 megabits a second. So you may have a 1 gigabit virtual interface defined for your VM, but they're only guaranteeing you 80 megabits a second. So that's well below the 1 gigabit per second you thought you had, and dramatically slower than what you had when you were running the application internally. So they obviously offer higher capacity virtual machines, but those are sold at a premium. You have to know enough to specifically select those and pay for the right to use them if you're going to be migrating applications from your data center into the cloud that are very network dependent. Now, when you look at the actual capacity measures, there are a few things to really take note of. Some key metrics here: available capacity and utilized capacity. So as I stated, this is really a measure of from where your users are to where the application is being hosted. This is not the metrics you're going to get from your firewall about how many bytes were sent and how many bytes were received. This is a measurement of the entire application delivery path and what is the highest point of constriction. Where's the highest level of congestion? And that is what is going to govern how fast your application can be consumed by your users. Utilized is obviously the largest point of congestion. Where is, whether it's on your network, your ISP's network, some other third-party provider network, or even into the SaaS or cloud provider's environment, where is the highest point of congestion? Which network interface is the most crowded that my critical application traffic has to fight with to get through from my users to that application? And obviously, the inverse of that is available capacity. How much of that is directly accessible and addressable by my application? So this is key to understand. It's something that's simply not possible to measure with traditional IT management tools because in 99% of the time, this highest point of constriction is going to be occurring outside of your network. You probably have plenty of bandwidth on your LAN and probably have plenty of bandwidth from your ISP, but you have no control and really no visibility into the entire application delivery path over the internet and into your service provider. Yet that's what's affecting and controlling your user's experience with these critical applications.
Sean, how often do we see sort of a difference between what the customer has bought and what they're actually getting?
Virtually every time. There's there's two different factors that affect that. If your application is being delivered over a long geographic distance, just the physics of how networks work are going to restrict the volume of capacity available to your application. That's typically not the problem. What is the problem is, as you adopt a SaaS service, you may have 100 megabits per second out of your office, but Salesforce is not going to give you 100 megabits per second. You're sharing their capacity with the 100,000 of other customers of Salesforce. So they're going to restrict how much bandwidth is actually accessible to each of your users connecting to their service and running. So, if we do this all the time, we're able to see the internet is high capacity, but as you get close to where these shared resources are being doled out to hundreds or thousands of users concurrently, they have to restrict how much capacity is available to each user, because they'd be dramatically oversubscribed if they didn't do that.
Thanks.
Okay. Jitter. So this is a metric that very specifically affects unified communications, voice over IP and video conferencing. So we do see a definite trend in the market going from, people went from traditional POT systems and in-house managed phone systems to voice over IP. There's a second transition happening where they're going to externally run cloud-hosted unified communication systems. And you're just introducing more networks that are outside of your control that will be affecting your unified communication environment. The metric of jitter is a little difficult to understand. It's really the regularity with which packets are delivered from source to destination. This doesn't affect traditional data applications. It's typically not a big deal to measure for email or web applications. As long as the packets get there, your app will be just fine. But for a real-time stream, like a phone call, like a video conference, you need the packets to arrive there in a very, very regular pattern, so you get that constant stream of audio, that constant stream of video being delivered. And the variance in the delivery of those packets is what jitter happens to be. Again, the codecs used by voice over IP and video conferencing are designed to handle some level of jitter, but if you get your jitter measurements upwards or higher than 30 to 40 milliseconds, you will start to see a degraded call quality and for both voice and video sessions. So again, this is something that's a little bit abstract, but as soon as this starts to affect your calls, it is immediately noticeable. This is your call will audibly degrade, and as soon as this happens, it's not affecting a personal call. It's affecting your CEO's call with their shareholders, because that's just your luck. And last is quality of service. So this is really something that enables enterprises to prioritize which of their applications get resources and capacity when there's not enough resources to go around. If there is constrained bandwidth, if there's more requests for bandwidth than that is actually available on the network, the applications that are prioritized in higher order QoS queues will get those resources first. And this is something that large enterprises use all the time to ensure that their business critical apps run, and personal activity, recreational activity. If there's enough resources, wonderful, you can watch that YouTube video. But if it's not, if the resources are constrained, I need my business critical applications to get the resources first. That's exactly what quality of service does. The challenge with this is it has to be honored end to end. And if your application is hosted outside of your environment, it's a SaaS service, it's a cloud service, you need to not only make sure your network is honoring quality of service, but your ISP and every ISP that your internet carrier peers with is honoring it as well. Because if at any point over the entire application delivery path, quality of service is not honored or altered in any way, it may not be in use at all. A great example of this is a large financial institution. They have massive amounts of bandwidth, but they had a specific outage. They went from their primary circuit to a backup circuit, and they needed to verify that their real-time stock trading app was getting highest priority. That is their business, while everyone else sending emails, trying to do voice over IP phone calls, or just surfing the internet, that is lower priority. they were able to identify their ISP was honoring their QS markings, but another provider that their ISP was peering with was not. And this is a real challenge. Their critical stock trading application was just thrown in with the rest of the internet traffic, and those milliseconds literally cost them millions of dollars. QS is only valid if it's honored end-to-end, and that's a real challenge to identify when that's occurring, because it only really comes to light when resources are scarce.
All right. Well, Sean, thank you for that. That was great. So I think Sean did a really, really great job of sort of showcasing not just the metrics and the importance of those metrics to end user experience, but also talking about some of the challenges that measuring those metrics, some of the challenges of trying to measure those metrics as you move into the cloud. So whether you're using SaaS applications or migrating internally hosted applications at a traditional data center to AWS or the like, the ability of IT to capture, see those metrics goes away. This lack of visibility into traditional devices that IT has relied on is just no longer available. And yet that infrastructure that you're now relying on can radically affect the performance in that end user experience. So I want to talk for a second about how Abneta solves this problem specifically. So the way I like to think about it is that Abneta allows you to regain visibility into these, as well as a lot of other metrics that we haven't talked about here. But we focus on providing monitoring, and this is from the end user through the application delivery path right to the App Store, right? So we do this using a unique and patented active monitoring approach that measures performance along the actual application delivery path rather than deriving performance data from data reported by devices. And as a result, we can do this without needing to own any of the infrastructure. And this makes Abneta ideal for monitoring as you move apps to the cloud or bring SaaS applications into your business. It's ideal for situations where you might have a large number of remote users or remote offices, where you're trying to understand what that end user experience is like for that user in the remote office who's telling you that the web app is slow, but you can't see it because you can't really understand what their experience is like. I'll end our little Abneta commercial here, but if you want to learn more and see a demo, I've included both mine and Sean's contact information at the end of the presentation. So please feel free to reach out to each of us, to either of us, if you would like to chat. So just in summary here, cloud computing, obviously great for delivering applications. It's also a great way to bring third-party SaaS applications into your organization that in a way that doesn't impact the way traditional client server would. But that being said, it creates these new challenges. And by taking away the visibility of these important metrics for measuring that end user experience. If you need to regain that visibility when you move to the cloud, I like to think that Abneta has the tools that can help you get back what you were missing. And so with that, we're going to turn it over to Q&A. Here's our contact information in case anybody wants it. I had mentioned also, we'll be, just as a reminder, we'll be sending out a recording of this webinar in case you came in late and missed a portion of it. And we'll include a link to that downtime cost calculator that I showed earlier in the webinar. Please follow us on social media or check our website or the blog, as it has more resources to do with this and other topics. And you can also request a trial of Abneta at our website. So please go there and request it if you're interested in learning more. And with that, I'll see, do we have some questions?
Yeah, we have a couple of questions. I think we just have time for one or two. But the first one is, what about other metrics? What about, and this is for you, Sean, what about all of the other metrics out there?
Yep, absolutely. We really focused on network performance metrics as they're universal. Whatever app you're running from the cloud to your users will be affected by these applications, these metrics. You need to pay attention to them. But obviously, if you are consuming a web application, there's a whole other set of metrics you should be paying attention to. If the underlying network is flawed, it's going to restrict how fast your application can possibly run. But just having a healthy network doesn't mean your app is going to be fast. You need to understand a lot about the web application's performance And that's why when AppNeta performs our active application performance monitoring, we're not just measuring the network. We are understanding what applications are on the wire, which applications are fighting for resources with your business critical apps, who's running them, how often they're running them, the resources used, but also interacting with the application through synthetic transactions. So basically interacting with the web app like a real user does to understand the performance inside the app. Web applications are not monolithic. Just measuring to the login page of Salesforce.com, for example, isn't really relevant to your user's experience. So to make sure we have a complete and accurate understanding of your user's experience, we have synthetic transactions actually going through the key parts of this web application, measuring all the key metrics on a per page, per object level to ensure users are getting a quality experience to really encompass the entire gambit there.
Yeah, I mean, that's what we showed actually when we showed the CRM application that we're running. So we're starting with the end user experience of what it's like using a synthetic transaction, but then we're adding to that the network picture as well. So what AppNeta can provide is this combination of these two sets of metrics to really give you a holistic picture of your application performance. Maybe one more, because we're over. So.
Yeah, we're a little over. So one more quick one is somebody wants a clarification around measuring with or without devices, how exactly we do that.
Sure. So we have a patented technology called TruePath, which basically fires small continuous bursts of packets over the internet using a variety of different protocols, ICMP, UDP, and we've recently added TCP. And using, looking at basically the return path of those packets and the packets that come back, we're able to discern the metrics along the application path, such as capacity utilized and available, as well as some of the other metrics that we talked about. What's really unique about this is that we can do this continuously with very low overhead, but we can also do it both single-ended and dual-ended. And by single-ended, I mean that we can have one of our appliances firing packets at a SaaS application to give us those performance metrics, even though we don't own the other end. Or we can operate in a dual mode where we have devices, whether virtual or physical, at both ends, and then we can get even more information about the path. But that's one of the sort of technology special sauces that we have here at AppNeta. Sean, you want to comment on it at all?
Yeah, this sort of continuous stream of traffic that Damien was mentioning is really designed to experience that end-to-end application delivery path. So if your application moves, if a different route is taken, we will detect and measure right now what is the performance available to your critical app. But this is all done in a way that's designed to be an absolute minimum of overhead. So this isn't slowing down your network or congesting it with measurement traffic. It's designed to run on any network and have an absolute minimum of overhead so that we're not consuming the resources you expect to be there for your critical applications.
All right, we're over, and we like to try and respect people's time. So we're going to end it here, but I just want to thank everybody, and Sean, thanks for participating in this. And again, please go to appneta.com if you have any further questions or comments. Thanks, everyone. Have a great afternoon.
Thank you.